So this is Lab 4 for Physics 2211, and I am Jaden Witecki. Here is a quick introduction to this lab. We will be working with oscillation and we'll be observing the provided video along with creating the simulation from GlowScript. We will be analyzing the change of energy of an oscillating weight. Here are some quick formulas and ideas. We have the spring force and the kinetic energy, as well as the idea of the energy principle, which deals with energy being neither created nor destroyed. In this lab, we hope to satisfy the energy principle. The first part of the lab involves the experiment video we were given, as well as adding the calibration and analyzing the point masses along the path of oscillation. Here's a video of this tracking occurring. With this tracking, we get the chart of X and Y values we will use to check against our simulation from GlowScript. Here's some of the code snippets from the simulation. We are given the mass, and I found the initial position and velocity based on the experiment data. We were also given g, the spring constant, and the relaxed length of the spring. I edited what was below that in order to use for the simulation, system energies, and whatnot. Here is the rest of the code. It is the calculation loop for the simulation, which is built on the starter code, just like the previous slide's information is. And we are just updating the initial energies, as well as some of the momentum principles and energy changes. Here are the resultant graphs from the simulation. The blue line on the right represents the model, and red represents the experiment. The lines differ due to experiment recording versus the simulation. And on the left, we see the energy change versus time graph, where we see that where the blue line is the change in kinetic energy, the red line is the potential gravity energy, and the green line is the potential spring energy. We can see the orange line is equal to 0, which is important for verifying we have satisfied the energy principle. So some follow-up and discussion questions. We are asking, does your model satisfy the energy principle? And from what we saw in the previous slide, where the orange line, or the right here, the delta E, the change in energy, is equal to 0. That means that we are satisfying the energy principle because the total energy is conserved and does not change over time. And using the data you obtained in Tracker, we want to make 2 separate estimates of oscillation periods, and by estimating the first period of oscillation from the X position data and the second by estimating the period of oscillation from the Y position data. We're comparing the 2 estimates and discussing. So the X I got from the X graph, and the Y axis we got from the Y graph. And just comparing the 2 periods of oscillation